Hi and welcome to another vector question on the Kirby Maths YouTube channel. This question says PQRSTU is a regular hexagon, and regular hexagon means that all of the sides are the same length, and that means that in terms of these vectors here, then we could put this vector q here would also be equal to this side because it's travelling in the same direction and it's the same length, and p is also one of these sides. P could also be part of the equilateral triangles that make up the hexagon. So as I said in the previous video, when we were using a parallelogram, you might be called upon to recall the geometric properties of the shape in terms of vectors. So I'm relying on the fact that I know that a hexagon is made up of 6 equilateral triangles and the sides are parallel to each other, and that means that this and this are the same length and they are also parallel. Okay, we need to express P and Q in these vector terms. So we're going to start off with the first one. We're going from P to Q. So if I am travelling from P to Q, I am first of all obviously not going to go the most direct route. I'm going from P to O and then from O to Q. P to O is travelling the wrong way along this vector here, so that is going to be minus P. And O to Q is travelling the correct way along this vector, so that is going to be plus Q. And that one is pretty straightforward. On the second one, SP, the vector SP. First of all, I have to work out how I'm going to get from S to P. So S to P is from here to here. Now, I could go all the way around here, S to R, R to Q, Q to P. Problem with doing that is that I've worked out PQ, which is going this way. I would have to minus that, so it's a bit complicated. I could just work out, because I know that these equilateral triangles are all the same, I go from S to O and from O to P, S to O and O to P. S to O is the same as this, it's the same distance, same direction, so it's a P, and O to P is a P, so that would just be 2 lots of P. Just for completeness, let me down here go completely the long way round. So I would also have SR plus RQ plus QP. Okay, so S to R is Q, RQ is P, and then I'm going the wrong way along this one. QP is the wrong way along, so this would be the opposite, so that would be plus a P and that would be minus a Q. Q, take away Q, they cancel one another out, and then I've got a P plus a P, which is 2P. So you can see that even if I went the long way around, I would still get the same answer as if I used some of my knowledge about hexagons. And finally, for part C, S to Q. Let's have a look at how we get from S to Q. It's part of this question, isn't it? S to R and then R to Q. So SR plus RQ. S to R, this is parallel and in the same direction. That's the same, so that's a Q. RQ is the same as SO and OP, so that's a P. And normally we would write them in alphabetical order just to make it a little neater. So P plus Q. We could, of course, have gone the other way around, S to O and then O to Q, that would have given us SQ again. This is the vector SQ. So if I did that, I would get a P. I've done SQ going the other way, so SO plus OQ. S to O is P, and O to Q is Q. So again, can you see that you get the same answer going both ways? Okay, thanks for watching.